Okay, I think we are ready to get started again. I'm a little bit confused because in the morning part of this workshop we had like twice the people, so I'm not sure if I scared them or something. Probably I should have said, although this is called a Groovy Intro Workshop, this is not about, we are not mere users here, right? This is not a workshop for Gradle users, it's a workshop for aspiring Gradle build masters. And so we've already done quite some complex things in the first part of the workshop. So first of all, we played around with the quick start build. So in that part we were a build user. Second thing, we declared our own tasks. So we already declared our own things. We declared this greeting task, for example, and then we even wrote our own greeting task class, right? So we are already in the middle of becoming a Gradle build master. So first of all, do we have any questions on the first part, what we did? Anything that, have we been working on it over the lunch or something? It's still not working? So the last thing we did was to discuss the solution of the custom task sample, where we wrote our own greeting task class, and then we added two tasks, both of type greeting. For one of them, we used the defaults, so it would print out hello from Gradle, and the second one, we gave it a custom greeting. So every property that you declare in your greeting class becomes available to the users of your class, and they can then customize your task and finally execute it. So that's how far we got. So let's continue from there. Okay, so now the question arises, when should you implement your own custom task class? Because we already implemented a custom task in two ways. First, we did it write everything in the build script, and we added a task action with do last or do first without having any class, right? We already implemented custom task logic without writing a custom class. And then we improved on that and wrote our greeting task class. Now the question is, when should you do the ad hoc thing and when should you use a task class? And in general, if your task implementation is more than just a few lines, you should always go with the class-based approach. The class-based approach has quite a lot of advantages, especially in terms of reuse. So if you implement it as a class, it's easier to reuse it in other build scripts or even other builds. It's easier to test it, for example. It's easier to work with that in your IDE, because as soon as it's a regular class, you can create a regular IDE project for it. Your IDE will understand it. If you want to, you can even implement it in Java then, and your IDE will understand it even better. So if you have to do something which is ad hoc, very specific, a one-time solution, and it's just 3 lines of code, it's perfectly fine to do it, inline it into the build script and not use a task class. Just declare a new task with a do last. But as soon as it's more than that, it's usually better to write a custom task class. Another thing is you can, for example, use JavaDoc or GroovyDoc on that and can generate some documentation. So it has several advantages. And writing a custom task class is really the first step towards separating the imperative part of your build from the declarative. And that's really important when you work with such a powerful tool as Gradle. You can easily make a mess of this. Imagine give someone half an hour of Groovy, a Gradle build script, and then let him go. And if he's creative enough, come back a day later and you'll have a mess, right? So with power comes responsibility. It's really important. Your build script should be lean and mean and declarative. It should just configure things. Like it should configure, where was it? It's a different slide, but it can declare some tasks and set some properties, but it shouldn't contain a big complicated implementation here. So everything that looks like production code, like an algorithm or something, that shouldn't be in the build script. And by putting that part, the implementation part, in the task class, you already have separated it, even if the task class initially lives in the build script. And then you can go on over time and move the task class out of the build script. And we'll have an exercise on that. So where else can you put your task class if you no longer want to keep it in the build script? And the build script, in the build script, only the declarative remains, and the implementation is moved to somewhere else. That's just a good programming principle, and it also applies to your build script. So I already talked a little bit about two phases. That first of all, Gradle evaluates all your build scripts, learns about all the information it needs to have, builds a data structure, a regular Pojo object model out of that, and only then makes up its mind as to what to execute. Two phases. And this is a central concept, and here we have it on this slide. And we call it the build lifecycle. And if there's one thing you take away from this workshop, then it's this slide and these concepts. Because this is extremely important to understand this to be successful with Gradle as a build master. And here's how it goes. Each Gradle build progresses in 3 phases. So no matter what you enter, whether you say Gradle tasks or Gradle build, or doesn't matter, it always goes through these 3 phases: initialization phase, configuration phase, and execution phase. Let's have a look at them. The more prominent ones are the configuration phase and execution phase. So often I only think in terms of them because they are the most important. But if we talk about the full details, then there comes an initialization phase before that. So let's go through them. In the initialization phase, Gradle learns about the environment. For example, it learns where the build scripts are located. Because in a bigger build, you can have many build scripts, not just one. So Gradle has to somehow find them. And that's one of the things it does in the initialization phase. So it's very, very early. It's like you drop someone on a new continent and he starts to look around. That's the kind of thing Gradle does in the initialization phase. At the end of the initialization phase, Gradle knows where all the build scripts are located. It hasn't yet looked at them, but it knows where they are located. And it also knows if you have a multi-project build. And we won't go into details on that today probably, but that's equivalent to a Maven multi-module build, for those of you who are familiar with Maven. So basically you have one huge project, but you don't compile it all at once, but it's composed of multiple modules that you compile separately and that have dependencies on each other. And for such a build also Gradle learns what are the names of those projects, how many projects does this build have, and how do they fit together. That's the initialization phase. After that, it moves on to the configuration phase, and that's where it evaluates all the build scripts. So if your build has 5 build scripts, then no matter what you enter on the command line, which task you execute, it will always evaluate all 5 build scripts. So the configuration phase is always inclusive in that it evaluates, at least if you don't get into performance tuning, by default it will evaluate everything no matter what later gets executed. That's a key concept to grasp. So what does it do there in the configuration phase? It evaluates the build scripts, means just run them as Ruby programs, and builds a data structure from them. A regular POJO object model that's part of the Gradle APIs. So if you declare some repositories in your project, then it will have a project object that links to a repositories object, that's a collection, and this contains an object for each repository that you declare. So a regular data structure. And at the root of that data structure is an object of type Gradle. You can also find that in the DSL reference. So if you picture the Gradle build model, that object structure, at the very root there is an instance of Gradle. Below that are all the projects, if you have more than them. Currently we only have one. Each project again has a set of tasks and lots of other information. Basically everything what you declare in a build script becomes part of that object model in one way or another. And then, at the very end of the configuration phase, only then Gradle will look at what you entered at the command line, which task you told it to execute. Until then, it doesn't care. While it evaluates the build scripts, it doesn't even know it doesn't even look at what you entered at the command line. It doesn't care at this point. It just collects all the information. And only once it has all the information, then it looks at what you entered at the command line. For example, you said Gradle build. So apparently you want to run a task called build. Then, from then on, it just looks at its data structure and its object model. It hunts for that task called build that you told it to execute. And hopefully it finds it. If it doesn't find it, it will fail and tell you it doesn't know about such a task. And if it finds that task, then that task might have dependencies on other tasks. So from the initial set of tasks that you provide on the command line, it builds then a graph of tasks to execute. It just follows the dependencies of those tasks. So it will what it ends up with is an execution plan. So a plan which tasks to execute will usually be a subset of the tasks declared and in which order to execute them. And that's where the configuration phase ends. So at the end of the configuration phase, it will know exactly which tasks it will execute in which order, but it hasn't executed them yet. And only then it transitions into the third and final phase, the execution phase, where it does the actual work. So it takes this execution plan and executes one task after another. Or if you run with the parallel mode enabled, it might run some of them in parallel, depending if they have dependencies or not. But only in the execution phase does it do the real work, like compiling your code, creating your archives, running your tests. All of that happens in the third phase, the execution phase. That is, if you get it right, then the execution phase is where Gradle will spend most of its time in, right? And so, and this should be very quick, maybe a few hundred milliseconds or something like that for the first two phases. And then the majority of work, depending on how much you have how much code you have to compile and how much tests you have to run. This might take a few seconds or an hour or whatever. Now, why is it so important? You have to make sure to do the right things in the right phases. So everything that you want to tell Gradle, every information you provide, you have to provide it in the configuration phase. And every time you want to instruct Gradle to do something like compile code, you have to make sure that it will do it in the execution phase. Otherwise, problems will happen. And basically, there's two things that can go wrong. You can do something in the configuration phase that you should do in the execution phase. And a symptom of that is if you implement some custom task or something, then you run Gradle. For example, you implement your own custom compile. And then you run Gradle tasks. So just show me the task, don't compile. And nevertheless, it compiles. You go like, what? I only set Gradle tasks, and why does it compile? And that's a symptom because everything is always configured, no matter what you execute. So if you get it wrong and implement your compile so that it runs in the configuration phase, then you will compile every time on every Gradle invocation, no matter which task you execute. That's a symptom of doing something in the configuration phase instead of the execution phase. There's also the other thing. If you do something in the execution phase instead of the configuration phase, so you tell Gradle, for example, about what version of your product you want to build, this version. This is a classical form of configuration. If you only tell it that in the execution phase, it might be too late. Some tasks have already run that require that version information, and you haven't told them yet what the information is. So that's another kind of problem that you will run into, that Gradle will kind of neglect some of the things you tell it because you tell it too late. Another example would be if you tell Gradle in the execution phase, so you have two tasks, foo and bar, and they seem to be independent, and only in the execution phase, while foo already runs, you tell it, oh, by the way, foo depends on bar, which would mean it will have to run bar before foo. So at that point, it's too late. It cannot adapt anymore. It's already running foo. So how could it possibly now run bar before foo, right? So at this point, it will usually either neglect what you are saying, or it will say, sorry, you're telling me that too late. So that's the kind of symptoms you get when you do something in the wrong phase. And we'll soon have an exercise coming up, very soon, in fact, and which is about nothing other than understanding the different phases. That's the whole point of the exercise. So we have two tasks here, hello and date, and both of them are very simple. I have one task action and print out. The one guy prints out hello world and the other one prints out new date. And now you are asked to improve this build script in a few ways. So for example, first you should make the date task depend on the hello task. If you remember on one of the slides, you have to figure out the syntax to make this one depend on that one, which means whenever date runs, it will first run hello, because the idea is hello produces something that date consumes. Okay, then execute date and make sure that it really executes hello first. Then play around with the Gradle tasks command and the Gradle dry run command. Dry run is handy when you want to make sure that all the tasks are executed in the right order without actually executing them. So it executes a real build, the dry run. It will just pretend that the tasks don't have any task action. So it will pretend that all tasks are empty. But otherwise it will run a full build. It will go through the full initialization phase, configuration phase, execution phase. It will make the execution plan, everything as always, except that it will mute all tasks. So the compile task will no longer compile, and the jar task will no longer create a jar. So that's great to simulate a run, basically. And then this is the important part of the exercise. You should add some print line statements, sprinkle them throughout the script. So some of them on the top level. Top level means not at the top of the build script, but outermost, outside of a task declaration. So here or at the very bottom. And some other print line statement, you should put, for example, here you're asked to put one inside the date task. So before the do last, not inside the do last, we already have one in there. But let's say between the date and the do last, or after the do last, in here. And then execute Gradle hello and try to make sense of when, in which order the print lines, you get the print lines, and why you get the print lines, and do you see all of them or a subset. Try to make sense of that. And if you understand which print lines you will see when you then run the task, and in which order, then you have understood the 3 phases, right? And in the very end, I'll take you through it. But first of all, try to make sense yourself, and hopefully you'll be initially surprised, because that will help you understand it better in the long run. Yes?
A question: when it goes and discovers all the other projects to build, is it based on the starting directory?
Yeah, so there's a difference between a multi-project build and a single project build. In a multi-project build, there's one additional file, a settings Gradle. And then the algorithm is, Gradle has a baked-in way to search for the settings Gradle. It depends on the current directory, and everything else follows from the settings Gradle. So the only thing that's baked in is to find the settings Gradle. And if it doesn't find any settings Gradle, it has a second, simpler strategy. If in the current working directory there's a build.gradle, it takes just that. But that's like the special case for when you have a single project build. The more general cases, it first finds settings Gradle, and then in the settings Gradle, that can configure how many build scripts are there, where they're located. So everything follows logically from that. Okay, let's give that a try. And if you need some help, then let me know. Is it clear, the assignment? You have the slides, right? So you have to look for how to declare dependencies, for example. We had it somewhere, I think. Here's some ways to make one task depend on another. That's one of the things you have to do. Yeah.
Which lab is this that we're doing?
5.
5?
So it's executing so this is clearly working just as a dependency part. You know, I did normal tasks, but what I'm asking about is, how come hello is not listed?
Yeah, that's actually, I can tell you, it's kind of part of the exercise, because it's a reason for why it attaches all, and it attaches all the orders and everything. And then the question is, which ones do you see without attach all? The general idea is that in a large build there will be many more tasks than the ones you interact with directly. So a bunch of them you will call explicitly, but the other ones are just implementation detail more or less, right?
Oh.
And so it has some heuristic advantage because it's a subset of the task by
Oh,
default.
Depends on is probably something.
It's a part of that.
So that's the only thing that changed.
Yeah, it's a part of that.
I see. Okay.
And I'll tell you.
I thought I'd done something wrong, so it was listed, but then I could run it.
Yeah.
Oh.
Yeah.
All right, first one does is read this whole thing.
Yeah, and then you have to follow up with which task. It's just a thing, basically, the rest of the command is the same.
So where do I get the assignment?
Sorry. So you should have. You were here in the morning, right?
No, I wasn't.
Oh, I'm sorry for that. Oh, because it's a 2-part workshop. I'm sorry, but I do have them, but you now probably have to set up Gradle first. We did that, all of that.
I got
Okay, so one zip file, and everything is on there, both all the labs and also the Gradle distribution. You probably don't need the Gradle distribution, but you just. Yeah, it's 1.6, and there's a labs directory if you unzip that thing, and you just go with that. And anyone else who wasn't there in the morning and needs some material? I'm sorry I didn't ask again.
I'm working my way. I'm on exercise 4 already, so.
Wow, cool.
Where are we on? So that
That's pretty impressive.
Are we on 5 now?
Yes.
You say top-level sentence statement is
I mean not necessarily at the top, but at the outermost level, so not nested.
Yeah.
So this is fine, but it could also be like here or in between, but not in the task. So, but this is fine, and probably one or two more at the very end, for example. So that is keyboard tabs. Yes, that's an error that we want on right now. Yeah, but it's required in our configuration. So if you open this, yeah, you have to get rid of the columns. Because that depends on column syntax, that's only if you have to have those slide, there's this variation where you put it as a name parameter, and so that's why we want it. I don't think the tool will be on that. Yeah, can be a little bit tricky because it's like script dealing language like. I think if I was were to do Gradle again, I would probably get rid of the first syntax. It's one too many probably. But it's not allowed. Like we want it to be good Groovy citizens, and in Groovy there's always 5 ways to do the same thing, and people love it. So that's a historical thing, more or less. Yes, exactly.
Then I rewrite this one, and it just goes. I don't understand why. I was just trying to make hello, and this hello doesn't depend on anything. How come is 3?
Yeah, go back to the slide with configuration phase, execution phase, and try to make sense of it. I'll clear it up after. But that's exactly what the exercise is about. Try to figure out, try to make sense of that. And once it clicks, then you've learned a lot. Like this is for a build master, this is the one essential thing to learn. So I think this is this exercise. And you can read, all many other things. You just read the docs. But this one you really need to understand and see a few times because everyone's surprised by that. I mean, I was surprised myself, right? But once you understand it, then it's kind of problem solved. And it will save you from many hours in the future if you
Yes.
from hours of troubleshooting
Yes.
once you've understood it. Question?
So the dash all on tasks. Otherwise, it just shows it only shows the week nodes. If you don't do the dash all.
Yes, that's part of the story. Yes. So the general idea is that a big Gradle build will have many tasks. Can go into hundreds, right?
Yeah.
But typically you only interact with a handful of them directly. So these are the ones that are most relevant to you, and the other ones are more in implementation detail. And so that's why by default with Gradle tasks, Gradle tries to only show you the tasks that it thinks are the ones you will invoke directly.
It's not smart enough. So if you do all, it shows them.
Yeah, but the good thing is you can control what it shows, and I'll talk about that once we get to the solution.
You're saying that one where
Yeah, so you declare 2 tasks here, and you do the same thing. So okay. Yeah, so the most regular syntax is to put the depends on information to the code of the day. Because this is the easiest one. This will correspond kind of to the second line. That's the most regular syntax I want to recommend. You can also do it differently. So the third line you can also do. If you do instead of your second task state, just replace that with the third line. But I recommend to do the most regular syntax, just task date early, and then in your area depends on without the column in this case. Otherwise, it can be next line. You're calling a method here. A method with this interface, which yes. Yeah, now the name of the okay. Another way would be to let's say this task is used by some other build script or a plugin or a view because just want to add the showing us how to stand. I could say here lines to show like okay and so on and so there's going to be a list of last. And this syntax with the color, that's a very special one. I think it's best to just forget about it, and it only works when you do it at the same time as the declaring. Column syntax you can't bring it later on. Whereas this syntax here you can separate it from the main declaration task if you want to. So the column one, the easiest one is to forget about it. There's one syntax variation too many. So this is the middle, so the top of the argument. Yeah, thank you.
So if you remember, we also did this.
So has anyone figured out why the print lines are printed in a certain order and why you see some of them but not all of them? Does it make sense to anyone? It's confusing at first. That's why we do the exercise. And that's why I'll talk about the solution.
Why am I'm not confused.
You're not confused?
Should I be confused?
It matches your expectation?
Not exactly.
Yeah, that's the problem.
So all of the new processes.
The configured code is executed in order.
Is there another question?
Yeah, the question is, I'm not confused by it, so you have something wrong.
Or you just make sense
Well, not anything, so I'm
Yes, right. It was also the data.
Much better.
Oh, there we go.
So it's about Are you ready to talk through the solution? I think quite a few people already got to the point where they are trying to figure out what's going on. That point was reached by quite a few people already. So let's talk this through. So here's my solution. I added a few print lines. You see, I added one at the very top and at the very bottom. By top level, I mean that it's not nested inside some block. And then we already had this one originally. That's the task action, right? That's the task action of the hello task. This one we also had task action of the date task, and we added one in here as well. And now we run task hello, and the question is what happens? Okay, so 3 phases, always keep in mind. So Gradle starts, we say Gradle hello. Initially Gradle doesn't care what we say. It will start with the initialization phase. In this case, initialization phase means just it finds the build.gradle. Because you executed Gradle from the same directory. That's how it finds the build of Gradle. Okay, it's a single project build, so initialization phase done once it has found the build of Gradle. Second phase, configuration phase. It actually, since Groove is a compiled language, by the way, it under the hood compiles the whole build script. And if it hasn't done so already, it caches it, but that's an implementation detail. So Gradle actually has to invoke the Groovy compiler to compile the build script. After it has compiled it, it can evaluate it. So it runs the build script just to learn about which tasks are declared and what their order is. Okay, so it starts from the top in the configuration phase. So this is what you will see first, print line top level 1. Very beginning of the configuration phase. Okay, then it comes here and says, okay, I have to add a task to my object model. It adds a task hello. Okay, this task has a task action, and I'm not yet executing that because that's execution task action. I'm just saving that off in case for later. So now you have a task, an object model with one task, which has one task action, but it's not executing. Okay, it goes further in the configuration phase. There's a second task, adds another task object. Oh, this one depends on hello. That's one of the ways you can add dependencies. So it remembers that date depends on hello. It's just another piece of information. Configures further, gets here. Okay, well, I'm not sure what that's supposed to tell me, but apparently he wants me to print something, so I do it. So this print line runs as part of configuring the build script, right? Okay, so that's the second thing you see. print line date configuration. And that's already confusing because you said Gradle hello, right? And so you wouldn't expect that something inside the date task would print. But the thing is, it's not yet running the date task, it's just learning about it. It's evaluating the script, and that's why no matter which task you execute, this will always be printed. And that's the confusing thing. If you wanted to only see that if you run the date task, then you would have to put it inside the do last. That's the big difference. So often a mistake is people forget the do last or put something outside that they should put in. And then it will execute for each and every Gradle build, and also in the wrong phase, in the configuration phase. And now imagine you do something expensive here. You go to a web service and fetch something and so on, and you accidentally do it in the wrong phase. That means each invocation of Gradle, even if you just say Gradle task, will now go to a web service, and you will have a performance problem. You'll say, oh, Gradle is so slow, and well, chances are you got the phases wrong, right? Okay, so then it learns about this task action, again just saves it off. So now it gets to the bottom of the build script as part of the configuration phase, so that it prints out that one. So now it has printed out 3 things as part of the configuration phase. Top level 1, date configuration, and top level 2. Okay, so it's done configuring, it has built its object model, it knows everything it has to know, and now, only now it looks at the command line. Oh, he wanted to execute hello, so I better search for a task called hello. It finds that in its object model and says, does hello depend on anything else? No, doesn't. So all I have to do is execute the hello task. That's the execution plan. And now we are done with the configuration phase, and it transitions to the execution phase where it executes its plan. And that plan is executing that guy, so it runs the task action. So it prints out that thing in the execution phase. So it would now be okay if that would be really slow, take a long of time, that's okay. In the execution phase you can take your time. I mean, as long as it takes, right? And this one you will never see if you say Gradle hello, because we are not executing that task, we are just configuring it. And because we are configuring it, you will see this line, but we are not executing it, so you won't say that line. So that's the solution. And once you understand configuration phase first, execution first, later, everything is always configured, but only a subset is executed, then you understand what we are talking about. That's a key concept to understand. So therefore, yeah, question?
No, there's no fundamentally different about the print line versus do last. Why? I mean, why does do last get evaluated but not run? But print line gets.
Yeah, first of all, because Gradle defines it that way. Gradle wants to have it that way, so we made it behave that way. So in other.
Okay, so that's only true of the things that Gradle has defined.
Yeah, that's essentially this do last is a method on the task interface. And Gradle implements that method, and it's a matter of how Gradle implements that method. Okay. So it's a call to a do last method that has one argument, which is this code block, like anonymous inner class in Java, like a runnable. And now this method can decide what to do with that code block. It could either execute it immediately, or it could save it somewhere for later execution. And the defined behavior for do last is, that's part of the Gradle docs of the model. So this is how you declare a task action, and a task action is always executed in the third phase, in the execution phase, and only if Gradle decides to actually execute that task. So this is deferred. It's like in callback-based programming, where you define a callback and pass it to some API, but the callback isn't executed immediately, like in JavaScript asynchronous programming, right? You register a callback, and then you make it a HTTP request, and you register the callback, but it will only kick in later. And if the answer never arrives, the callback won't kick in ever, right? For example, just to give an example, and this is similar. You register a callback and tell Gradle, if you ever decide to execute that task, and only when, then run that code.
So that's true of everything that was created as an extension of the task. We did that earlier. So it's true of tasks that have been created.
It's true of anything you pass to do last or do first.
Well, no, okay, but those tasks earlier we created the task ourselves.
Yeah, with do last or do first, and we also did it as a class.
Oh wait, never mind. That's implemented as a task.
So yeah, so sometimes the curly braces. Here, this is a closure, a code block, and sometimes the curly braces, if you implement the class, has also curly braces, but it's a different thing. So this is really something like in Java, it would be a runnable or something, an anonymous inner class. In other languages, it's called lambda. It's what the Java 8 lambda will be. Or in Ruby, Python, it's most often called a lambda, and most modern languages have it. Scala, Clojure, they all have it, and Groovy has it as well. And syntactically, you call a doLast method on the task object. So it's a regular task pojo, and it's an interface actually, and you will find the doLast method there. And of course, there's also an implementation there. You will find it, and it takes one argument. So you could do the parents here, open parents, close parents. But in Groovy, you can always leave out the parents when you call a method if you want. So here we leave them out, and this one here, the open close curly braces, this is what we call a closure, which is a code block, one or more statements like a method body. But additionally, you can pass them around like a value. So you can pass them to a method or store them in a variable. So that's what's technically happening here. And basically, you can, from seeing that and not knowing about Gradle, you wouldn't be able to tell what happens in what order. You have to know how Gradle defines it. And you can learn about that here or in the Gradle documentation. If you go into the DSL reference, task type, and then read the docs for doLast, it will tell you that whatever you pass to it will only execute in the execution phase. But just from looking at that, at the open braces, you wouldn't be able to tell if it's executed immediately or later.
The do first, what phase will that execute?
Also execution phase. So doLast and doFirst are just two ways to add a task action to a task. If you remember, we had that model. One task has a list of actions, and doFirst adds it in the beginning and doLast at the end. And then in the execution phase, all of them will be executed in order.
So if you only have one action to take, it doesn't make any difference?
Exactly. If you only have one, then the two are the same. The only use case is if you, for example, say I have a task greeting of type greeting, you give it a type, it already has a task action. And then you might want to add a little bit of logic before or after that, and then you would either use doFirst or doLast. If you declare it from scratch and it only has one, then doLast and doFirst are same thing. And most of the time, actually, you don't have any task action because you just reuse something like the greeting task. You say task greeting, type greeting, that already gets you the one task action that comes with the greeting class. And in most cases, this is all you want. In most cases, you will then configure it like we had greeting with something, and that's all you do. And it's relatively rare. If you have the use case you want to do a little bit before or after, then you will add it to first or to last. But if you create a task from scratch like we did here, because we are practicing it, and don't reuse an existing behavior, then you have to have a do last or do first, otherwise your task has 0 task actions and is not very useful. So that's it. Any other questions on this exercise? Why things are executing in that order?
So that one line that's outside of the last block, I put that in the configure closure. Is that the same?
Here?
Yeah, putting it in the configure closure or just putting it.
Well, what's a configure closure? You mean this?
Yeah, exactly.
Something like that?
That's what I did.
Did that work?
Yeah.
Didn't it look like something? Usually it looks something like this. It also has another parameter. So config. I mean, it's definitely not necessary here. It's a no-op more or less. There's a special case where you would use the configure. For example, I can quickly show you. For example, you have a task greeting 1 of type greeting and a task greeting 2. And in practice, you might have many more tasks of the same type. That makes perfect sense. And let's say you want to configure them in the same way. You want to give them the same greeting. And then you have 10 of them. And you don't want to repeat yourself because that's repetitive. So the question is, how do you configure them at once? And in this case, there would be a very nice way. The nicest way would be you could say tasks with type greeting that gets you all of them. And then in here, you can configure them with the same syntax as everyone. That would be the idiomatic way. But if I would use the configure way, then I would say configure, then I'll give it a list of the 2 tasks, greeting 1, greeting 2, and then here I can again configure them in one go, both of them. So that would be one use case for that special configure method. But you only use it if you want to configure multiple things at once, and if there isn't a more convenient syntax as the tasks with type. So it's quite a special case. Okay, anything else? Yes?
I don't know if I missed that part, but if I have, say, 2 dependencies, like task date depends on hello, comma hello 1, comma hello 2. Can I guarantee that the order of which
No, order doesn't count in Gradle. So there's a difference between Gradle and. So for example, we also have a task, let's say task hello 2, whatever that is, and then we want to express that date consumes the outputs of both hello and hello 2. So then you could say this, or with my preferred syntax, the more regular one, you put everything in here and say depends on without the column hello, comma hello 2. And so this has different semantics in Gradle and in AND. In AND, if you do that with a target, the syntax is very similar, and you say that date target depends on those two, and actually what it means in AND is both of them have to run before date, and then you say, if possible, AND, please, if you can make it happen, also execute hello before hello 2. But it's not a strong guarantee in AND. It's what AND calls a soft dependency, and most people actually, or many people, think it's a strong guarantee, and they absolutely rely on that, and then you flip something somewhere else in your build XML, and that no longer holds. So in AND, that's a soft task dependency. It says both of them must run before date, and this should run before that. And in Gradle, this is different. In Gradle, this is just a shortcut. This syntax here is just a shortcut for that. So you say both of them have to come before date, but you don't imply any order between the two. So most of the time, actually, you don't need the order between the two. It's completely overused in AND, that feature, but sometimes it can be really important, and Gradle 1.6 added that feature. But you have to be explicit. What you can say in Gradle 1.6 is hello 2 must run after hello. And then you get back the AND behavior. The thing is that in AND you have no choice to opt out from that. So even if you don't need it, you specify it and people start relying on it. And at the end of the day, what we see with large AND builds, it contributes to having brittle builds. And that's why Gradle doesn't do it by default. Because if Gradle is free to reorder them, it can do lots of wonderful things. It can now start to run them in parallel. But if we would have to assume that this always means run hello before hello 2, then it would mean we could never run the two in parallel. And that would be a real pity, just to give one example. Okay, I think it's time to move on. We still have some stuff to do. Let me check. When did we start? 1:15, so we are halfway through the second part. So let's see how far we'll get. Okay, we did that, custom tasks, we did that. Okay, now let's move one layer up. Let's try to get away from the AND nitty-gritty execution layer. I mean, it's really important because this layer is, the task layer is the one who actually does the hard work and compiles your code and so on. But you don't necessarily want to declare all the tasks manually in your build script. Because then that's the problem with AND basically. It's fairly low level. You have to declare all the targets, all the tasks, all the dependencies over and over again. And there aren't any strong features to abstract over that. I mean, there are some ways in AND to abstract over that, but it's hard. And this is where you get to the next higher layer in Gradle, which is the layer of plugins. So what is a plugin? Basically, it's very simple. A plugin is just a packaged build logic. So a plugin can do exactly the same as a build script. So everything what you have done so far in your build scripts can be done by a plugin. It's only a more reusable, a more modularized form of a build script. So this means in particular that plugins run in the configuration phase. Plugins are about configuring stuff. Not about executing stuff. So what plugins typically do, like your build scripts, they will add some tasks. And that task may then run in the execution phase. The plugins don't compile something themselves. Instead, they add the task that will later compile your code. So they do similar things that your build scripts will do. Set good default values, add some tasks, add some repositories, dependencies, whatever you want them to do. So it's a good way to get configuration out of your build scripts and make them more reusable. For example, if in your enterprise you have a corporate artifact repository like Nexus or Artifactory, and you have 1,000 builds and all of them should use only Nexus, let's say, as the artifact repository, then either you could have 1,000 build.gradles, which for 1,000 builds, each of which again declares the one repository. That's okay, it's just a little bit repetitive. Or you could write your own company plugin, which does the same thing as a plugin. So then you have a My Company plugin, which declares Nexus with your URL as the repository, and then there are even ways to get that automatically, to get Gradle to apply that automatically. So what you can achieve by that is that you get that out of your build script. If that's a given in your enterprise, then why should every build script repeat that, right? So the plugins are a way to package up build logic and make it reusable, and make it testable, and so on. As you have more and more complex logic that's reusable, think about moving it out of the build scripts, the commonalities, and write a plugin. So reuse, modularity, these are the reasons why you'll write a plugin. And of course, Gradle already comes with a lot of plugins out of the box. Okay, already talked about that. So a plugin will often add tasks. It will configure existing properties. It will add, that's an interesting one, add configuration rules for future elements. So that's quite something sophisticated. So for example, what a plugin could do, let me think about that. It could say, whenever the build script adds a compile task, I put JUnit on the compile class path. Not sure if that's it makes a lot of sense, but that's the kind of thing that a plugin can do. So it could either add itself, add a test task and configure it to put JUnit on the test class path, or it could form a general rule and say whenever a user in his build script declares a test task, even if he doesn't say it, I put the JUnit on the test class path. That's a rule, a more generic way to express something. I'm making up a rule of configuring things that the user will add later. So that's an example for a more powerful thing that a plugin can do than just adding a fixed set of tasks. So how do you go about writing your plugins? You can either write them as build scripts or as objects, or what I really mean here is classes. So a regular Gradle build script can be a plugin. We call it a script plugin. So now you've written the build.gradle. If you move part of that out into a other.gradle, then it's already a plugin. We call it a script plugin. It uses exactly the same syntax as your main build script. And then you can have this include mechanism where you can include one build script into the other one. You may know that from scripting languages like Ruby or Python, or Perl, where you have some kind of include statement, which means the same as copying one script into some location of the other ones semantically. And the same thing you have with Gradle, and that's the easiest way to reuse build logic. For example, if you do lots of dependency management in your build script, it gets bigger, you take everything that's related to dependency management, move it in a separate file, call it dependencies.gradle, and in the main script you apply it. And that already makes your build script easier to understand, because you have now one build script which is focused on dependency management, and another one, the main one, which does all the rest. So that's the simplest form. We call it a script plugin. That's really good if you want to share logic in one build, between many build scripts in the same build. If you want to share between multiple builds, like all builds in your enterprise, you can even do that with script plugins, because what we allow you to do is you can push the script plugin, the .gradle file, to any web server in your enterprise, and then your builds can apply them from their URL. So that's the simplest way actually to share across your enterprise. You push something, build.gradle to a web server, and all other builds can apply it in the build script by its URL. However, that has a few drawbacks, and the biggest drawback right now is that we unfortunately don't cache that. So if you use apply from URL, then if your build is not online, it will fail. So that's something we'll fix at some point, but that's something to keep in mind. If you do go to the simple way of reusing build logic, then your build has to be online in order to work. Most more sophisticated plugins actually ship as jars. So the ones that come with Gradle, or the ones you will find on Maven Central, third-party Gradle plugins, they don't ship as source code, but they ship as jars like any other Java library. And the way you do that, and probably I'm already talking about the next 5 slides. So this was the script plugin. Let's take a quick look at that. Here's your main build script. That's the one that Gradle evaluates. And now you moved the task declaration out into some other .gradle. So this task declaration you moved into my plugin.gradle, and then in the main build script you say apply from : and then the name of the other build script. It's a path relative to the location of this build script. So that's the simplest way. And that's often used to modularize build scripts within one build, just to make them more comprehensible, basically. So that's the script plugin. And then comes, that's the remote version, where you say apply from HTTP. And that's really nice because it's so low tech, so easy to share, except that we don't currently cache it, unfortunately. So for some people that's okay, because they say if this server is down, then Subversion is down as well, and if Subversion is down, they're done anyway or something like that. But in general, I think today the requirement is that your build should work when you're offline, and in this case, this is currently not a good solution, but we are working on it. The more sophisticated one is to implement the plugin as a class. Remember, we also implemented the task as a class eventually. So this is the most sophisticated way. And again, if your plugin gets complex, it pays off to invest a bit more and write it as a class and have a regular code project for that. So you build that thing like you build your production code. So you create a new project, put that in, build it, and push it to your enterprise repository as a jar. And then other builds can get the jar from there and reuse the plugin. So it's a little bit more involved because you now need to push a jar somewhere and bring it in again. But on the other hand, writing it as a class has quite a few advantages. First of all, we now cache it. So all the builds that use that, they have to get it once, and then they have it on their local machine in their cache. So you can now build offline. Second, you have all the IDE features here available. This is now regular code. You can write it in Java as well. So you have all your IDE features available for writing that. So you get more IDE support than when you are scripting a build script. And then you can write tests for that thing. And as your plugins get more complex, again, we say you should treat your build code like your production code. So you should write tests for that thing. And ideally, you write both unit tests and acceptance tests for that thing. And we have a separate session, I believe it's tomorrow, or was it already today? I think it's tomorrow, which is just about testing. Was it today? I'm not sure. Tomorrow, yeah, which is just about testing your tasks and plugins. And testing works much, much better if you implement it as a task, as a class. And how does it work? You implement a class that implements the Gradle plugin interface, and it only has a single method, apply, and there it gets its context. You remember in a build script, the implicit context of a build script is the project object. So in your build script, you can access anything that's available on the project object. For example, let's look here. I can, in my build script, say version equals. I can give my project a version. Version is 1.0, and now where does this version property come from? And the answer is it's a property on the project class. So it's really something declared in a regular Java class. And if you write your plugin as a class, you lose this implicit context, because this is a bit groovy magic that this is shorthand for project.version. That's a groovy feature when you write scripts. But as soon as you transition into the class world, this is now a regular groovy or Java class. There is nothing implicit anymore. So how it works is that when Gradle invokes your plugin, it will pass you the project instance, and you now can use that like any regular API. So instead of saying version equals something, in here you now have to say project.version equals something. So it's a little bit more involved, more like regular coding, more like writing production code. But on the other hand, you will now get code completion on project dot, which you currently, for simple cases, you already get it in some IDEs, but for complex cases, you will only get the code completion here currently and not in your build script, because that's much harder for us to implement. And other than that, it's very similar. Here, what does it do? It adds a task named myTask and adds a task action. It uses a bit less groovy magic here, so it looks more like regular groovy or Java code. But essentially it does exactly the same. So it gets the task container project.tasks, which has an add method, and you can add a task with a certain name, and then you can access it and say my task do last. Actually, that's, I think there's, oh yeah, okay. So you add a task with that name, get back a task object that comes from, it's an interface from the Gradle API, and then you add a do last, a task action, and add a print line. If you were to write that in Java, at this point you would have to start with an anonymous inner class. You would have to have, say, something like my task do last new runnable public void run, and it would come out to the same thing, but it would involve more boilerplate, because Java before 8 doesn't have lambdas. Okay, now once you have declared such a plugin, how can your users use it? How can they bring it in? And it's a slightly different syntax compared to the script plugins. The script plugin was apply from, and the binary plugin is apply plugin. apply plugin colon and then the name, in the easiest case, the name of your plugin class. So here we were in a package my.org and we named the class my.plugin. So in the build script they say plugin my.org.myplugin. There's a nicer way, because usually you don't want to have a fully qualified class name. That sounds like coding, right? That doesn't really fit a build script. So it would be much nicer if they could just call it by some name, apply plugin some name. For example, apply plugin Java. That's how you apply the Java plugin that ships with Gradle. And now the question is, eventually Gradle has to find a class, because their binary plugins are always implemented as a class. So it has to have a way to map this name to a class. And how does it do it? The plugin has to ship a descriptor. So if the plugin ships a properties file, there's a special properties file that you can put in your plugin jar, where you say, my name is this and my implementation class is this. And if you provide that properties file with your plugin class in the jar, then people will be able to apply it like that. If you forget about it, then people will have to do it this way, which is less nice, basically. So when you write your own plugin class and ship it as a jar, you should always include the descriptor, the properties file, so to give it a name.
How do you resolve name conflicts?
Good question. Yeah. Currently, we don't have a namespacing here unless you do it yourself. But there is no first-class namespacing mechanism. So far, it hasn't bitten us, but we are starting to think about it, because we're seeing more and more third-party plugins, and just telling them, please. Well, I could tell them, please use org.mycompany.myplugin, but I'm not sure if that's good enough. So we might eventually add some namespacing control or something, but we don't currently have it. What you can always do, I already had that once between a third-party plugin and a Gradle plugin. You can always drop back to the class. If that's unique, then it's not as nice, but at least it solves your problem. And here it says, that's already detail, the descriptor. This is where you have to put it. It's a resource file in meter.inf in your jar, Gradle plugins. Then you have to name it after the plugin name that you desired. For example, if you want to call your plugin Java, you have to name the file java.properties, and the file needs to have exactly that content. One line, one property called implementation class, and the value is the fully qualified class name of your implementation class. And this is the example of the Java plugin that ships with Gradle. So if you look into the Gradle code base, into the resources, you will find a meter.inf Gradle plugins java.properties file with exactly that content, and it maps this Java, the name, this identifier to this class name. And so in your build script, you can say this, apply plugin colon, and as a string Java, and Gradle will be able to map it to the corresponding class name. That's how it works. And that's already quite advanced, right? That's not your first day plugin probably. I'm already telling you quite a lot. So this is already the most sophisticated form of writing Gradle plugins. So don't get intimidated. Yeah, you could even apply a plugin to something other than a project, but this is really, I think this is just showing off how cool it is. I've never, in 3 years of Gradle, I've never used that. So a plugin always has a context. It configures something in the Gradle object model. And 99.9% of all Gradle plugins configure a project. That's their context. They add tasks to the project, or they set the version of the project or something. And in a multi-project build, you will have multiple projects, and then you need to apply the plugins individually. So for example, you have two projects, one has Java code, one other has Scala code, then you want to apply the Java plugin only to the project with Java code, and the Scala plugin to the project with Scala code. So the scope of a plugin is project, but that's nothing that's built in, that's just the way it happens to be for 99% of our plugins. So you could write a plugin that, as its scope, it just configures jar tasks, individual jar tasks. And then you can say, I want to apply this plugin to jar task 1 and jar task 2, but not jar task 3. And then the plugin will do its thing, whatever that is, set some conventions. It will do its thing for the jar task 1, jar task 2, but not for any other jar tasks you have. But that's just showing how generic the base mechanism is. And I haven't used it in practice. And Gradle doesn't ship a single plugin. All the plugins that ship with Gradle, they will always do they have project scope, they do something to a project. Okay, so which plugins do we ship out of the box? This slide used to get longer and longer. We split it into 2 pages, and it didn't fit in 2 pages anymore. And finally, someone was smart enough to put in a link. So now the full list of plugins is listed in the Gradle user guide, and this is like the first 6 of, I don't know, 30 or something. So just to give you a quick idea, of course, everything about building Java libraries, compile, test, package, upload Java projects. Of course, for war projects, there's a war, and for ear projects, there's an ear plugin, and this Java one is for Java libraries. There's also one for Java command line applications, that would be the application plugin, so several in the Java space. Then we have several code quality related ones. So if you want to use one of those tools, checkstyle, findbug, PMD, a couple of others, JDepend, CodeNug for Groovy, we have plugins for them. If you want to publish to a Maven repository, if you want to publish your own artifacts, your jars or ears to your enterprise Maven repository, that's what the Maven plugin is for. We support a couple of other languages, like we have great Scala and Groovy support. If you write your production code or test code in Groovy or Scala. We're also starting to get really, really good C++ support, and we are really proud of that, because we want to be the build tool for the enterprise. And I haven't seen an enterprise which doesn't have a whole lot of C++ code, right? And so we want to give you one build tool which you can use to build your Java, maybe your Java backend, your C++ special backend code, and your .NET front end. That's our vision, right? And we already had a C++ plugin for a long time, and it was actually used in practice by some of our clients, but nevertheless it was very limited. So for a tiny fraction of production code it would work, but it was too limited. And now we have one of our bigger clients is funding a full-time Gradle engineer just to improve the C++ support, and we are allowed to put everything into the open source Gradle plugin. So that's a win-win, right? And so he's, at least for the next 4 months, he's already occupied with improving our C++ support. And we will get really great stuff there, like dependency management for C++, matrix builds, and all of that with a high-level language, not like with a make or ant language, but really high level. And if you're interested in that, we have a talk on that. I forgot if it's today or tomorrow. I think it's tomorrow, by the co-founder of Gradle, Adam Murdoch, and the engineer Des. The two do it together. So if you're interested in the C++ story, then I encourage you to attend that talk. Yeah, we could go on. So there are IDEA and Eclipse plugins. That's one way of integrating with the IDEs. You just generate the project files. There's another way. You install a plugin in Eclipse or IDEA. If you're interested in IDE support, then come to my talk tomorrow evening, which is just about Gradle and IDEs. It's the last slot tomorrow evening. And have a look in the Gradle user guide. There are many others. And of course, there are also quite a few third-party ones which are listed on the wiki, or you will find in Maven Central. You will find quite a lot of third-party plugins. And the longer-term goal is we want to create a portal. One place where all the third parties put their Gradle plugins, where the documentation is, where you can rate them, and maybe you know that from other full-stack frameworks like Rails, the web framework. They have a Rails plugin portal, the one place to go for all third-party plugin portals, and we want to provide the same for Gradle. And I think that will be the next step. We already have, I think there are at least 100 third-party Gradle plugins, but I think if we have a great portal with a great experience, then we'll get 1,000 and not 100. So I think that will be a real enabler to enable the community to provide high-quality Gradle plugins. Okay, I won't cover that one. Plugins are buying plugins. Yeah. Let me see. I want to get to that exercise, applying plugins. Okay, so one thing that you may not have heard of, which is really cool, the Gradle build language is extensible. You can extend the Gradle build language. You can create new vocabulary that your users can use in the build script. And that's something very special. If you think about Maven, the POM, it's also declarative. It's really declarative. You say, these are my developers, these are my dependencies, and so on. But the POM is fixed. It has a schema, and the Maven developers thought that up like 10 years ago, and it's set in stone, more or less. So if you're lucky and your requirement can be expressed in the POM, then it's really great. Then you really have in Maven a declarative build. The problem is, if you have a requirement that you can't natively express in the POM schema, then the only thing you can do is you can write the Maven goal and configure that. But that essentially means dropping back to the ant level, because then, for example, what could it be? For example, what information I cannot express in the POM, not easily. For example, you have multiple editions of your product. your software project, a free edition and a premium edition. And you want to somehow say the free edition contains these classes, and when I build the premium edition, it should also add in the jar those classes. This is not a first-class concept in Maven, and they cannot possibly dream up every possible feature, right? And so what you can do, you can write the Maven plugin and configure the Maven plugin with there's a free edition, there's a premium. Now the problem is if there's another Maven goal which needs the same information, you need to configure that with the same information again. And if you have 10 Maven goals which all need to know which editions exist, you have to configure them all repetitively. So you're back to the ARM level where you configure each ARM task with the same information. And with Gradle, the declarative model is extensible. You can make it so that users can write in the build script additions, free, premium. And then any Gradle task, your plugin, you would implement that as a plugin, and your plugin can then feed this into information in all the tasks that need it. So you stay completely declarative, and yet you can introduce your own vocabulary. And one example of that is the Google Android plugin. So the new command line build tool from Google for Android is completely based on Gradle. The old one used to be based on Ant, right? And there's recently switched to Gradle, and one of the reasons for that is that Android has very specific requirements for a build. Android builds are quite complex. For example, you can talk about different flavors of an application. That's a concept in Android, so you can have a free flavor and a premium flavor. You can have multiple build types like debug and release, like you often have in C++. And then you need a combination of those. So I want to build the debug version of my free flavor, this kind of thing. And they extended the Gradle build language that if you say apply plugin Android, right in your Gradle build script, you can now suddenly say additions or flavors, and you can list your flavors, and you can say build type and list your build types. And the Android plugin will suck in that information and will give you lots of tasks. You just say, I have a free flavor and a debug build type, and the Android plugin will turn that into a task, build free debug, for example. So you can stay declarative, but can express your requirements in the known and accepted Android language. So that's a nice thing, that your build scripts stay really high level, readable, and maintainable. Okay, now I talked a long time, and this is the technical details, how you extend the build language if you write a plugin. So you have a simple Pocho, you write a class, so that could be build type or flavor for the Android plugin. And then you have to add that to the Gradle object model. This Gradle object model where there's a Gradle object, the project object, the task object. Like you can add something to the JavaScript DOM, to the browser's DOM. JavaScript can add some new node to the DOM. You can add some new Pocho to the Gradle object model. And this is the details how you do it. You create a regular Pocho, and then you say project, that's the Gradle project object, .extensions.create, give it a nice name, like build flavors, and then say, give it the class. And you just do that in your plugin, and then the user in the build script will be able to say my, and that's an instance of your Pocho, and in this code block he will be able to configure it. So you just write the plain Pocho and one line of registration, and the user will get this build language for free. Actually, the project dot, you could leave off the project dot, so that in the user's build script, if you name the thing my, then in the user that applies your plugin could in the build script just say this just my. And what this would do is would simply configure your Pocho here, and then your plugin can go on and make use of that information. So you can just stick in new Pochos into the Gradle object model, your users configure it in the build script, and your plugin can use that information and, for example, create new tasks and configure them based on that. So I hope it was a little bit clear. It's a very powerful that you can extend the declarative language, but that's high end, right? Most users that even write plugins don't do that. That's high end, but it's very powerful. Okay, and that gets us to the next lab, and I really wanted to get to that lab. So let's see how much time we have left. So we have 2:45. Yeah, we have 20 minutes. That's more than enough for this lab. So let's have a look. That's already quite involved. So you're more and more on your way to becoming a serious Gradle build master. So here's the next step. Okay, so let's see. There is already a plugin there in the plugins directory. There is a simple script plugin. A plugin could be as simple as that, right? It's a info.gradle, and it simply just declares a task in its own build script. And now your main build scripts can simply include that, and so every build script that includes this one gets an info task. The ones that don't do it don't get an info task. As simple as that. Okay. So the first thing you should do is you should apply this info.gradle plugin to your main build script. So you will have to think which was the right syntax for applying a script plugin. There was this apply from and the apply plugin, and it's probably one of them. Once you did that, run Gradle tasks from the command line, and this info task should now show up, because here you include that secondary build script, the script plugin, so the task should now be there. And then it already gets tougher. You are asked to turn that script plugin into a binary plugin, so into a class implementing the plugin interface. And again, you can write the plugin class for right now. You can write it right in your build script. So declare an info plugin class, and that has the same behavior as this script plugin. Okay, then declare a task named info that has the type info plugin. And you should be back at the original functionality, only that the plugin is now implemented as a class. So you need to apply the plugin by its class name, and then you should again be able to execute the task. Okay, now it gets a little bit further. The sixth one, I think, do you even have that? I think you don't have it. So this sixth one, the project extension, that's a little bit too tough. So we leave that. We have some time constraints, but you should get until 5. Let me see. Yeah, so let's try that now. And if you have any questions, let me know. And you will need the slides, of course, to figure out the correct syntax. So you will write the task class, plugin class at some point, and you will apply the plugins, and probably you will initially apply a script plugin. So that's the initial solution will be more like this, and then you will refactor that into a class-based plugin.
You mean a jar file basis?
We don't go as far as putting it in a separate jar, but in this exercise, but we write it as a class. And usually then the most sophisticated form of shipping a class-based plugin is in a jar. But that we have an exercise on that, but I'm afraid we won't get there in time. But we can have a look at your build source stuff after the workshop if you're still interested. So first step is really simple, applying the script plugin. Then refactoring that to a plugin class is a little bit more involved. By the way, is there still one of these sticks floating around?
All right.
Ah, cool. Thanks. Yeah, there is a task of exit. So if you look that up in the cell reference, it's called exit. And here's the Java program, there's Java exit, otherwise we use the plain exit. So you can find it in the cell reference or also in the user guide. If you just do a browser search in the single page user guide for exit, then you find something. Anyone here for my Groovy class this morning? Anyone? So do you know what that is in Groovy speak? Technically, what that resolves to?
A map. No.
There is a map involved. So what's apply? It's a method. So that it comes from the project object. So it's project.apply, and then what's the rest from column that? Exactly, yeah. It's a method call of the apply method, which is declared on the project class, and it passes one named parameter. Groovy has this feature, and the name of the parameter that it passes is from, and the value is this one. And here you could have the parents around here if you wanted. Apply open parents, and here close parents, but in Groovy you can leave that off. So technically that's a method call that passes one named argument. But that's not how I usually think about it, right?
How does Groovy pass named arguments? It passes them as a map.
Yeah, it collects them all into a map, and the receiver, the implementer is the poor guy, because he just gets one argument passed, which is the map, and it's no longer kind of strongly typed the signature of the method, you know. So it's Groovy has half-baked name parameters. They're really great for the user, but not so great for the implementer, because you have to implement the method in a certain style so that users can enjoy name parameters, right? So that's what I call poor man's name parameters. Actually, a build script, the script plugin cannot have a package statement. You should get an error if you do only a class, but a script cannot have a package statement. Yeah, so that should work in general.
But this one doesn't actually.
Yeah, no, this one doesn't work because, yeah, it's the same thing again. For now, you should leave the plugin class in here, and I can show you later how to move it out. You cannot bring in a class with apply from. You can only basically call into another Gradle script, but you cannot bring in the class declaration via apply from. So once you get to the point where you implement the plugin as a class, you should put that class right into the build.gradle, not in the other one. Yeah. So.
Oh, you can't put it in the entity.
No, you can put it in other places, but we don't have time to talk about that. But we can't put it into the intro Gradle. Yeah, in the build script you can't do package statements, so just get rid of it. So if you would package it as a jar, that's all fine. Oh yes, plugin and then so if you do the generics, then you have to do a smaller than Gradle thing. Yeah. Yeah, that's the Java syntax. You can leave off the whole thing and just say it as plugin. Ruby allows that. Yeah.
Okay, so then that's up. This would be this then.
And now comment how they apply from. That was the first approach, and now we replaced that with the class-based. Yeah, the implementation was really good. Now you still need to apply that plugin in the rest of the build script. So for a script plugin you have apply from, and for a binary plugin that's slightly different. Was there another question? No? Okay, we have 5 minutes left, 6 minutes. There's something I simply have to show you in case you haven't seen it, because it's so cool, and so I would like to end this right now and have a quick look at my solution. The solution that wrote it as a class. So it's a class that has this apply method, and in here, actually this one is a little bit more sophisticated. I think I opened the wrong class here, but at the end of the day, it's a plugin that has an apply method, and you apply it with that syntax: apply plugin colon and then the plugin class. So that's what it looks like. Just my implementation here is a little bit more complex, so I could leave off that line here, and that's what it would look like. And if I, actually you already, let's wait a second. You have. Yeah, if I manage to upload the 50 megs, I think I will, then you'll have all the solutions. So you can, if you want to keep the solutions, you can go over it later on. So there's this one thing, there's lots of other topics, and we can't make them all, but there's one thing I just need to show you in case you haven't seen it. It's not a new feature, we had it for quite a while, but it's still a fantastic feature. And this is inputs and outputs. This is about incremental build. Have you ever seen Gradle telling you a task is up to date? So when you run the same build multiple times, it will become much quicker. And the way is, how does it do that? How does it know that it already compiled it last time, nothing changed, so it doesn't have to do it again? And this is about inputs and outputs. And I have to abbreviate that a little bit. But I will show you. This is the kind of work you have to do to get that feature. So all the Gradle built-in tasks already have this information. Each task has a set of inputs, that's the information it requires to do its work, and it has a set of outputs, that's what it produces. And one example is the compiled Java task that ships with Gradle. The most important input of a compiled Java task is the Java source code. That's what it operates on. So the Java compile task that ships with Gradle declares the source files as an input. And the most important output of the Java compile task is the class files that it produces. So if you look at the implementation in the Gradle code base, somewhere it will say build direct output directory. That's where it puts all the class files, and that will be annotated with add output directory. So there are a couple of annotations, and I won't go into the detail, that allows you to declaratively tell Gradle what is it that a task consumes in terms of information and what does it produce. For example, the Java compile task has more inputs than just the source code. All the compiler settings, the compile class path, all these things are inputs. It's information that the Java compiler needs. And the Java compile task has only a single output, which is the class files that it produces. Okay, so the Gradle built-in tasks already have that information, so they are incremental automatically, but you can get the same thing if for your task classes you add the right annotations to the properties. And it's quite simple. Once you get the hang of it, there are only like 6 annotations, and you get a ton of stuff for free if you happen to do that. It's optional, but if you do that, Gradle will do all sorts of, how did they say it, magic sauce. So it's pretty awesome. And I'll show you just one thing that you will get. You'll get many things, but do you remember the quick start? The quick start was the project we used at the very beginning. So if I bring that up again, this was the build Gradle, this Java library, and it has a bit of source code. And first of all, let me execute that code. Just run a full clean build, let's say. So I clean everything, so it has to run everything again. So you see that nothing is up to date. Now I run it again, and it should be a lot quicker. Everything up to date. So it knows that nothing changed compared to the last run, so why should it have to compile again? And all of that it figures out just because you tell it these few annotations. Or in this case, we did it. Okay, now, and it's a generic mechanism. It doesn't know anything about compilation. It doesn't understand what compilation means. It just knows what the inputs and outputs are. And now let's see what emerging behavior you get from that information. And that's pretty cool in case you haven't seen it. So here's the class that we are compiling. It's some simple Java person code, right? And so let's say I'm the developer of that class, and I remove a field. So I would expect that it has to recompile it, right? So run it. Yeah. And let's see. Compile Java is no longer up to date, so it has to recompile that. So this output of compile Java, the class files, are an input to the char task. So the char task noticed, oh, my inputs have changed, so I have to run again. So char also runs, not up to date. Then, for example, the char is an input to the test task, because the test task is testing the stuff in the char. The test task sees, oh, my input, my class path, my test class path has changed, I have to run again. So pretty much I have to run everything again. Now, of course, if I do it again, haven't changed source code, everything up to date. So now it gets really interesting, and keep in mind, this mechanism knows nothing about compilation in particular. Now I just add a comment as a developer. I add a comment in my source code. Now what do you think happens? Everything has to run again? I just change the source code, right? See that? No, it's not the same. Almost everything is up to date. Only compiler ran, everything else was up to date. And how can that be, given that this mechanism knows nothing about Java compilation? And the answer is the following. I just added a comment. So input of compile Java changed. So compiler says I have to run again. It runs again, but produces the same class files as before, because I just added a comment, doesn't affect the output. So the input has changed, but the output was the same. So that feeds into the char task. The char task says my input, my class files haven't changed. I don't have to run. I already have that chart up. So I'm up to date. That feeds into the test task. The test task has as its input the char, says nothing has changed. I don't have to run. So that's really cool and really smart without that thing knowing anything about Java compilation. And I think that's really cool. And if you add these few annotations to your own task, you will get similar behavior. And in a large build, you can save tons of time, right? Especially your developers. You change a little bit of code in a huge project, run it again, boom, everything up to date, and just in one corner, little compilation or something runs. So that's, I think, a really cool feature. We've had it for a long time. That's what we call incremental build. Yes.
What does it use to determine whether things are up to date?
For everything file-based, it takes hashes, like Git does. So it hashes the whole source directory recursively. So it's really reliable. And
so it's not date-based.
No, not at all. So it hashes everything, the inputs, the outputs, and if it's just a compiler flag or something, then it serializes the Java object. And for everything file-based, it hashes it. So that's how it works. And that's really cool and can help you to get really fast builds. And the good news is we can even make it even faster in the future. We have plans to make it even better and smarter and faster, but already in its current incarnation, if you get used to that, it's like you don't ever want to use a build tool which doesn't have it. It's like, it's addictive. If you get used to that, you already go like, if something's not up to date and you expect it to be up to date, you go like, why? This should be up to date, you know? And by the way, if you want to know why a task is being rerun, you run with Gradle-I. So Gradle clean, for example, -I for info logging. That's quite verbose. especially for a full build, but it will tell you, here we saw it, exactly I'm rerunning the task test because this file has changed, for example. So if you're uncertain, don't understand why it reruns something, then run with info logging and it will tell you exactly. Okay, I think my time is over. Thanks a lot for coming. Thanks a lot for getting hands-on with me. I hope you learned something and hopefully you'll enjoy the rest of the conference. Thank you.